Good morning, everybody. Welcome to the hydraulics and hydraulic machines lecture. In today's lecture, we focus on the problems related to the force exerted by a jet on a plate which is hinged at the top. In the previous class, when we solved the problems, we solved the problems related to the plate, whether it is in vertical position or inclined position or it is in curved position. All these three cases, the plate is fixed. Now, in today's class, if it is hinged, what will happen? How to solve such type of problems? So, fixed things to a hinged thing, hinged at the top so that it can freely basically move. If a force is applied, because it is hinged at the top, automatically it moves. So it is hinged like this, just like this. This is the plate. If a force is applied, automatically you see how it is moving. The moment force is applied, so hinged means at the top, it's like this. It can rotate. It can rotate about this hinge. So if a force is applied like this, what will happen? Automatically it moves. The plate moves actually. If that is the case, how to really solve such type of problems? This is what today's question is, and we will take up that question. So our today's problem is, as I mentioned, it is only to solve the problems related to a hinged plate. So the question is, what is the force exerted by a jet on a hinged plate? So this is the question. The meaning is, for example, there is a plate like this. All the previous examples which we have done are such that they're all fixed. Now, in today's class, we are doing actually a problem related to a hinged plate. That means the plate is like this. So, this is your plate. It is hinged at the top. This is the hinge portion, and this is the plate. In such a case, if a jet strikes it like this is the jet, then automatically what will happen actually the moment jet strikes the plate, this plate will shift to like this. This is how the plate shifts the moment a force is applied. So now our job is, if it is moving like this, how to calculate the force, right? And then actually subsequent questions in that. So this is the problem actually. So how to solve this type of problem? That is the question. Suppose how to solve, I will straight away go into the problem rather than explaining the theory portion of the whole thing. Rather than that, for you, whatever is required, that much only I am explaining, right? How to calculate? What are the questions that will arise? So the questions that arises in such type of questions are, number one is, in order to keep this plate vertical, what force is to be applied here? This is the first question. If a jet of certain diameter or area is striking the plate at its center, Thereby the plate is actually a swing then in order to avoid that swing, what the force should be applied opposite to it. That is the first question. Second question is how much is the angle of inclination? The first angle of inclination. Angle of inclination will be how much? This is one question. This is the other question. Angle of inclination is such that this is what we mean by angle of inclination. So this angle of inclination is how much? That is one of the questions people generally will ask. The second question is in order to keep it in this movement, how to do the problem. That means how to you can avoid the swing by applying how much force. So this is the two things. So if one formula you remember, all others can be solved. I'm not going into the derivation of how you are going to really solve this. I'm straight away coming to the point. Whatever is required for you, whatever is required for you is sine theta is equal to rho a v square by the weight of the plate. This is the answer for your things. What is rho here? Rho is the mass density of the fluid. Generally, we are taking only water. It will be 1000 kg per meter cube. And A is the area of cross section of jet that will be given to you. V is the velocity of jet that also will be given to you. And then if theta is given, generally the question, this is the formula that you should remember. And that's again, if questions are if theta is given, you will be asked to calculate weight of the plate, or if weight of the plate is given, you will be asked to calculate theta. All subsequent all subsequent questions can be answered based on the above. That this is how generally the problems in this it is going to be. So therefore, knowing that, let us see how to calculate. I will take the first problem for your things. A jet of water of 2.5 centimeter diameter with a velocity of 10 meters per second strikes a hinged, because the moment you see that question strikes a hinged square plate, the cross section of the plate is square plate of weight 98.1 newtons at the center of the plate. The plate is is of uniform thickness. Find the angle through which the plate will swing. So already I mentioned straight I come to the answer solution. We know theta is equal to rho A V square by W straight. What is rho? Water. It is 1000 kg per meter cube. What is A? It is equal to pi d square by 4 because we need to calculate. So pi d square 5 into what the diameter is given 2.5 divided by into centimeters he has given 100 pi d square by 4. So if you calculate that it is going to be point 0.00049 meters square. Please check this, gentlemen. Then what is V? They have given V is equal to 10 meters per second. What is W? They have given W is equal to 98.1 newtons. So all the units also clear. SI units rho 1000 kg per meter. This is meters per second newtons. Therefore, theta is equal to 1000 rho into A is 0.00049 into V is 10 divided V square divided by W 98.1. So it is equal to, we are getting basically, it is best not theta, it is sorry, sine theta. Sine theta is equal to this. Therefore, sine theta is equal to how much it will be basically? What I got is 0.499. So it is theta is equal to basically 29.96 degrees. Please again repeat. I will just make it. The correction is it is I sine theta. I have written properly. No issues. Here only I just forgot. So rho a v squared by w. So this is theta. This is simplest problems in this topic. It is absolutely nothing to worry. You will definitely very easily you can solve the problems. Let us go to the second problem. A jet of water 30 diameter. The moment you have seen, you should be able to calculate the area. 30 diameter strikes. The question when while reading strikes a hinged. That word, the moment you read, you should be able to take it. Square plate at its center with a velocity of 20 meters per second. The plate is deflected through an angle. Now, angle he is giving in this through an angle of 20 degrees. See the problem difference in the then angle is given means what will be asked. Then the question is very clear. Find the weight of the plate. Weight is given, angle. Angle is given, weight. Find the weight of the plate. Then a little bit addition. If the plate is allowed to swing. The plate is allowed to swing. What force is not allowed? It is allowed, okay. If it is not allowed to swing, what force is required? At the lower edge of the plate to keep in vertical position. Very simple. Again, see it. What are the data that are given? Solution. We will take it one by one. Rho is equal to, water it is 1000 kg per meter cube. That is first answer for us. Then A is equal to pi d square by 4. So he has given pi into d is equal to how much he has given? 30 mm. So 30 into 10 to the power of minus 3 whole square pi d square by 4. So if you calculate that 0.30, you're getting 7068. Please check all the things. So meter square. So A is also over. V is equal to, he has given 20 meters per second. Fine. Then our answer is sine theta is equal to, always we can write rho A V square by W in the case of hinge plate. Therefore, W is equal to rho A V squared by sine theta. So if that is the case, then W is equal to, we'll write rho is equal to 1000. Fine. A is equal to 0.307068 into V is equal to 20. V square is 20 square by sine 20 degrees. So if you solve it, you're going to get basically this is 826.6 newtons. So this is what the W. That first answer is over. Now the second answer is if the plate is not allowed to swing. If the plate is not allowed to swing, that means the plate is in vertical position only. So, for example, if you take it, this is the plate. He is not allowing the plate to swing. So, this has to be in vertical position only. This is the hinge actually. This is the plate. Now, the jet is striking at its center like this with a force F. Now, what he is asking is what is the force P to be applied here so that you can keep this plate vertical, because if you allow it 20 degrees angle, what is the weight of the plate? That all we found. So if it is like this, then what is the this height he has given? For example, we take it, this is h, right? Then naturally this force is previously acting at the center, it is h by 2. So now what I can take it, this is the hinge portion, right? So now if I take moments about hinge. Therefore, F into H by 2 minus P into H, this is equal to 0, right? If I put it like this, so what will happen? F is nothing. Then it is equal to F into H by 2 is equal to, right, P into H. This is the answer. Therefore, P is equal to, what will happen actually? It is nothing but F by 2, right? So what is F? Vertical position. If the plate is in the vertical position only, F is equal to what? This F is nothing but rho A V square. because it is in vertical position only. Rho A V square by 2. So what is rho A V square by 2? Already we have calculated previously. Rho is 1000, A is 0.307068 into V is equal to 20. V square is 20 square by 2. So if you calculate, P is equal to 140, basically 1.36 newtons. So what I have done extra here is only to keep the plate vertical without moving. Then what is the force to be applied in the opposite angle? So this is the second. So these are the questions that you can get in this particular topic actually. I will do one more problem before closing this hinged plate thing actually. So the problem is like this. A jet of water. While writing the problem itself, please try to understand the data of diameter, because all the data will be there only, nothing to worry. 25 mm. So when the moment you see this, you need to calculate the area. Strikes a 20 centimeter by 20 centimeter. Actually, people normally what do is this 20 centimeter by 20 centimeter, they see, they calculate area like this and they put instead of jet area this. But remember, the area which we require in the problem solving is the jet area, not the plate area. Square plate of uniform thickness with a velocity. So all the answers have come. Rho is known. Water means the moment water you have seen, rho is 1000 kg per meter square, the meter cube. Whereas the moment diameter is in, A is equal to pi d square by 4. The moment mm is given, it means actually to convert into meter into 10 to the power of minus 3. The moment you have seen the velocity 10 meters per second. So all the ingredient parameters to calculate rho e v square, you got it from this. Where the jet is striking at the center of the plate, which is suspended vertically by a hinge at its top horizontal edge. The weight of the plate is 98.1 newtons. The jet strikes normal to the plate. What is the force must be applied? What what force? What is no? What force must be applied at the lower, what force must be applied at the lower edge to keep the plate vertical. Till this, we have solved already just in the previous case. Until now, we have solved already in the previous problem. So, what is small addition? If the plate is allowed to deflect freely, what will be the inclination of the plate with vertical due to the force exerted by jet? So there are two cases in this. Let us solve very simple problem. I mean, nothing to really think so much big about this problem actually. So if I take it again for your understanding sake, this is the hinge portion. So this is the vertical plate, right? This vertical plate hinged at the top. Now what is the question? You can write it this as a hinge. Right now jet is striking at the center. Actually this is where the jet is striking. Fine. Then next so this plate length he has given 20 centimeters. If you see it, right, that is over. Then what is his question is, in the entire first question is, what is this force P? The first question is, what is P to keep plate vertical? This is the thing. So if I take this the moment it is 20, this is 50%. That means at the center it is 10 centimeters. So if I write it, if I take the moments about the hinge, taking moments about the hinge, right? This is F into H by 2 is equal to P into H, or F into H by 2 minus P into H is equal to 0. Anything is all right. Therefore, P is nothing but F by 2. This is the first thing you should understand in such type of cases. Then what is F? What is F? If the plate is kept vertical, F is equal to, we know it is rho A V square. So this is the first formula that which we have learned. Therefore, what is P for us? It is rho A V square by 2. So if it is that, then what is rho? 1000 into A is equal to pi by 4 into D is how much diameter has given 25 mm, right? 25 into 10 to the power of minus 3 pi d square into V is how much this fellow has given 10. So V square is 10 square divided by 2. So if you calculate from that, you are going to get P is equal to 24.5 newtons. This is your first answer. Very simple. What is your second answer? You need to get what is the angle, if angle basically. This is the question. How much it is, if it is allowed to deflect freely, what is the angle? So what is the angle which we know already the formula? Nothing difficult. Sin theta is equal to rho A V square by the weight of the plate. This is what the formula for us is. So now if I take it like that, then in such a case, already whatever is given, rho is equal to 1000. We know A is equal to pi by 4 into 25 into 10 to the power of minus 3 whole square. Then V is equal to 10. So V square is equal to 10 square by W is equal to what is the weight of the plate that fellow has given actually in this problem for us. The weight of the plate is 98.1 newtons. So, so therefore, sine theta is equal to what is the answer that which we will get? Sine theta is nothing but actually we are getting zero point 0.5 if we see, right? Therefore, theta is equal to how much you are going to get 30 degrees. Solve simple problems only. So if you remember like this, straight away we can do any problem in this. Here I will stop this three problems I have solved. In all the three problems, if you see it, the whole entire thing rotates around 2 points only. Those 2 points are those 2 points. If you take it actually, what are the problems that which we are solving here in this particular thing? If you see what problems we have solved here, you take it. Yeah, what problems we have solved? Number one is in the case of a hinged plate, how really we can solve the problems. In the case of a hinged plate, the moment the force is applied at the center of the plate starts deflecting, the plate starts swinging. So, angle of swing is one of the important factors. If you want to find out what is the angle of swing, then you should know what is the weight of the plate. If the angle of swing is given, you can find the weight of the plate. Then the third problem is if an opposite force is applied at the bottom of the plate, it need not be at the bottom. At any point you can apply. Only how to solve such type of problems is it's only taking the moments actually about the hinge, and some of the moments you should put equal to zero. Then the moment you put like that, you are going to get the answer. I have solved because most of the problems, in order to keep it vertical, the force will be applied at the bottom in the opposite direction. But remember that if somebody want to apply the force in the opposite direction at some distance from the hinge, then you take that distance only. There is nothing basically specific that you must take only at the bottom. If whatever the distance they say, that we will use it. So these three problems, if you really understand, then you can solve any problem related to the hinged plate problems. With this, I will stop this lecture here and take some more problems in the next lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.